Hi guys, in this video I'm going to be doing a follow-up to my previous video about my weighted average cost of capital calculator, and in this video we are going to be explaining kind of the code within the program, explaining what's happening, where values are getting pulled from, what equations we're using, just to give you a better understanding of the program itself. If you're going to be using this program in your valuations and getting your discount rate from this program, it's important to understand where your values are coming from, just so you're able to justify your discount rate. So to start, we're just going to look at this kind of chunk initially. I broke up the code into chunks, so we're going to be going over each chunk by itself. But to start, this chunk is the modules that we have to import, so all of our code can actually run properly. This actually, it's important, but it doesn't really define any variables. It doesn't do anything for us. It simply just imports these modules. But next we can look at this chunk here. This is all of our variables. It defines everything that we're going to need in our calculation. So as you can see by the first four variables here, they all have inputs. So this is where the user has to enter in a value, and whatever the user enters, that's what the variable gets set to. So for example, for TKR, it is equal to the input of the company's ticker. So if you were to put AAPL, then TKR would be set to AAPL. And that's the same for the tax rate, the debt borrowing rate, as well as the equity weight. For debt weight, it is simply 1 minus equity weight. And then these next three variables here, as you can see, period input, interval input, and beta cutoff. If you watched my beta calculation video, these look very familiar because in this calculation for weighted average cost of capital, it does not use a industry-wide beta. It doesn't unlever the competitors of your company and then relever to the capital structure of your company. It simply just uses your company's beta that you enter, and it does that, or it calculates that, by using the program that I created previously. And so it sets the period input to 5 years, interval input to 1 week, and beta cutoff at 10% or 0.1. So basically the beta it's going to be using is a 5-year beta calculated with weekly data, and it has a cutoff of anything greater than the absolute value of 10% for the week would be considered an outlier and removed. The only problem with this is that if you were trying to find the weighted average cost of capital for a company that went public 2 years ago or 3 years ago or anything less than 5 years ago, you're going to have to actually change the hard code. It's very simple to do. So if your company went public in 2019, let's say, then they only have about 2 to 3 years worth of actual data. So you get an error if you ran this because the program is looking for 5 years of data. But you can simply change this 5 to a 2, run the program, and you should be fine. If you're calculating or trying to find the weighted average cost of capital for a company that went public, let's just say 8 months ago, then you're going to have to change this whole line and change it to 6 months or 8 months, whatever it may be. So kind of depending on whatever company you're trying to get the WACC for, you can change this accordingly. And again, it's pretty easy, but by standard, it is set to 5 years, calculated weekly with a beta cutoff of 0.1. And again, you can change all of these values within the hard code to whatever fits you best. After kind of just doing my experiments, this way was kind of like the best standard inputs. So this is what I put down for the variables. Next, we have this variable called RFR. That stands for risk-free rate. Next, we have COD, which is cost of debt. And then we have cost of equity and our WACC. So all of these are set to 0 right now because they aren't actually defined. But when we define them and calculate them later in the program, they'll be updated with new values. So the next portion of the code here is this little chunk here. And basically what this does is it goes to Yahoo Finance and grabs this value here. So as you can see, tickers, you see this caret TNX. And if you go to Yahoo Finance and you go to the 10-year, this is caret TNX. So basically what this code or this chunk of code does is that it looks for the 10-year yield. It goes to its history and it grabs its last quote or its previous day's close and divides that by 100% to get a decimal. So if you were to kind of find this information on your own, what the code does basically goes to Yahoo Finance, goes to historical data, goes to the most recent day, and grabs its close. So that is what the risk-free rate would be when you run the program. And again, this updates every day. So currently I'm recording this on April 16th. So the most recent close date is April 14th, but it will grab the most recent date for whenever you are running the program. The next thing we have to calculate is, or find, I should say, is the equity risk premium. So how I calculate this, or kind of draw from a website, is there's a professor at NYU who is a valuation professor who posts equity risk premiums on his website every month. I found them to be the most reliable and most kind of correct, and it's what I've been using in my valuations. So what this code does, it basically goes to this URL. So if I was to copy this and paste this, it would take you to his website, and as you can see, if you go down here to implied equity risk premium, and then implied equity risk premium on April 1st, 2022, which is the most recent month from when I'm recording this, is currently at 5%. So what this code basically does is that it goes to his website and it grabs that value, and then it divides that by 100 to get a decimal. It looks kind of confusing within the code itself. However, you have to kind of, if you were to highlight this value, go here and then go to, or right click and go to inspect, it basically finds it within the HTML of the website itself. So the code's a little complicated to understand, but it basically grabs it from his website, and it should update whenever he updates it on whatever month. The code should also update as well. Next thing we're going to do here is this whole section is the beta calculation. This code is the same code from my previous video and my previous beta calculator that I released to you guys. So I'm not really going to go over explain this code. If you want more explanation on how the beta is calculated, you can watch my previous video. And next, we go into our cost of debt, cost of equity, and our WACC calculation. So for cost of debt, it takes the debt borrowing rate times 1 minus the tax rate. For cost of equity, it takes the risk-free rate plus the beta that we calculated using the code above times the equity risk premium. And then for our WACC calculation, we do equity weight times our cost of equity times 100, because this is all in decimals right now. And then we have debt weight times cost of debt times 100 as well. So for our WACC, we are going to get a percentage, not a decimal. And then it simply prints weighted average cost of capital for whatever the company's ticker is, and it gives you your WACC as a percentage, and then finish up with copyrights. So that is the fundamental of how the code works and where the data is drawn from. I hope this kind of gave you guys a clear understanding on where values are getting pulled from, what's being kind of working on behind the scenes. So now I hope that when you use this, or if you use this to get your discount rate for your models, you actually understand where the value is coming from. And again, if anybody has any questions, you can either leave them on the comments of this video or email me. My email is in the description. So thank you guys for watching, and I hope this video helps you guys.